Okay, so can you see my slide?
Yes.
Okay, so let me start. So thank you for very kind introduction. And so first of all, I would like to thank Inoue-san and Dawson-san for giving me the opportunity to talk in this nice seminar. And so in this talk, so I will talk about the AI-driven software development in computational material science. In particular, so I will focus on how I use AI coding in actual situations. So this is a figure so I frequently use in this kind of seminar. So we physicists uh, always suffered from the old code or messy code. And so the appearance of AI changed the world. And so AI might help us from this situation. But there is pros and cons. There are both negative and positive sides. And so I will talk about the details of the positive and negative points in much more detail. Anyway, so this is outline of my talk. So first, I give a brief self-introduction. So I briefly explain my research background. Then I will explain the generations of AI coding. So now we are in generation two. So in this generation, so AI automatically write a code. And the speed of coding is very fast, typically 100 times faster than human coding. So this is a big advantage. And so how to use this speed of AI coding is a main task for the computational material science. And so then I will explain how to practice agentic AI coding. So AI is very useful, but AI is not perfect. AI has two big limitations. And so I will explain the details of that limitations and the solution to them. Then I will explain my experience of agentic AI coding. And so by using agentic AI coding, so I develop a Julia mVMC. So mVMC is a software for many variable variation multiple methods. So that is originally written in C language. And so very recently, so we have rewrite that mVMC code in Julia. And so by comparing the speed of Julia mVMC and CMVMC, so unexpectedly, I have found the bottleneck in CMVMC. So I think so this is a prototype of cross-language optimizations. Anyway, and so in addition to that, so I give a brief explanation of the development of the supporting tools. And so in summary, so I want to discuss about what should we do in this AI era. So this is a self-introduction. So in 2004, I became a master student of ISSP, so Institute for Solid State Physics. So my main research field is a strongly correlated electron systems. And so after getting a PhD, so I have started to develop the official method for treating the strongly correlated electron systems. And from 2015, so I have started to develop the open source software package for treating strongly correlated electron systems, such as H5. So this is a software for exact diagonalization. And so another one is mVMC. So that is a software for variable, many variable variation multiple method. So through the experience of this development of the software package, so I feel that the development cost of the development is very, very huge. Of course, there is many good things for developing the software package, but the cost is very huge. But in this era, by using the AI coding, so I now feel that the cost is largely reduced by using the AI coding. So I will talk about that in much more detail. Anyway, so let me explain the generation of AI coding. So I think so generation of AI coding is divided into three generations. So in generation zero, so this is first generations. So in this generation, so we use a chat box to use AI. So one famous example is a chat GPT. And so to use the chat GPT, so we use a chat box. And so for the coding, so we copy and paste my own code in chat box. And so I asked the AI to modify the code or identify the bug in this code. And so, yeah, that is very useful. And so that is very surprising result since so AI is um, very good at pointing out the bugs or correct the source code, modify the source code correctly. And so after that, so in generation one, so the editor which user AI appears, such as a VS Code Copilot or Castle. So by using this AI editor, so to write a code, so we can use a autocomplete. So that is a very useful function. So by typing the seven initial characters of the coding, such as a for loop, so by inputting the first characters of the code, so AI automatically completes all the necessary functions automatically. So that is very useful. And after that, so very recently, in this 1 year, so Claude Code or Codex appears. So we call this generation 2. And so in this generation, so AI works automatically. So that means that AI automatically write a code and automatically identify the bug, and so automatically use Git. And so using Git, so AI automatically Git commit or Git push. So that is a very surprising result. And so that is very convenient. And so in generation two, so by using AI, so the code speed of the coding is very fast. So typically 100 times faster than human coding. And so this speed is a big advantage. So how to use this speed of the AI coding is a main task of computational material science. So in this generation, there is a many AI. So the main problem is that which AI should we use for coding? So to explain that, so I wrote a short article in this URL. So if you are interested in, please take a look at this article. Anyway, so in this generation, so the AI coding consists three parts. In the first part, so human give an instruction to AI. So please implement this function or please modify this code like this. And so based on that instruction, so AI did automatic coding. And so in some cases, AI automatically add the test. And so after the implementation, so AI automatically write manuals. So that is 100 times faster than human. And so in the last, after the implementation, so the main, most important part is approval. So we should approve the result of AI. And so that approval, of course, includes the responsibility. So we human should be responsible for the result generated by AI. So that is most difficult part, I think. But so the speed of the AI coding is very fast. So how to use it is a very important task. Anyway, so sometimes so you might feel so the wayward about letting AI code. But 100 times fast is uh very, very how to say very useful. And so this is an analogy with traveling. So if you want to travel from Tokyo to Osaka, so the natural and common choice is to get Shinkansen. So by getting Shinkansen, so Shinkansen brings you from Tokyo to Osaka within 3 hours. So, but if we choose, so walk from Tokyo to Osaka, so it takes much more times, typically 100 times more, and so it takes about 10 days. So if your purpose is to arrive to arrive at Osaka. So that is a natural choice using Shinkansen because it is 100 times faster. So that is the same as in the coding. So AI coding is 100 times faster. And so if your purpose is not coding, if your purpose is the getting result from the coding, so if so, you should use AI coding because it is very 100 times faster. So nowadays, so hand coding is out of date because so that is that is not effect that is effective only for the limited case, such as the educational case. Anyway, so to start the AI coding is not too difficult. So to spread the effectiveness of the AI coding, so we held a hackathon, Comp Hack, so on this March at Okinawa. And so we have we had three useful lectures in this hackathon. And so the slides of these lectures and the documents are available in this URL. So if you are interested in, so please take a look at this document. And so in the pre-event survey, so we have found so most of the participants of this hackathon, about two-thirds, had never used agentic coding. But all the participants in within 3 days, so they can use agentic coding, and so they achieve the variety of results using AI coding. So this is an example of the achievement of the hackathon. So one person tried to use a quantum tensor train technique. So that is a kind of the tensor network technique, and so the person want to apply this technique to the image compression. And so the person has no prior knowledge on the tensor networks, and so he said he never used agentic coding. But in this hackathon, so by using the AI agentic AI coding, so he succeeded in perform the quantum tensor train image compressions, and he has a benchmark with conventional JPEG compressions. And so another example is the implementation of the dynamic mean field theory. So this is a typical method, standard method in the strongly correlated electron systems. And so the person who tried to implement this says so he has no prior knowledge, and so he never implemented dynamic mean field theory. But so in this hackathon, so within 3 days, so he succeeded in implemented this dynamic mean field theory, and he gets a sound result. And so if you are new to agentic coding, so it is very easy to start agentic coding. So if you are interested in, or so if you reduce the cost of the development, so I strongly suggest you start the agentic coding from now. Anyway, so let me explain the limitations and limitations of AI coding and solution to them. Of course, AI is very useful, but AI is not perfect. So there are well-known two limitations. So one limitation is AI has no long-term memories. So here I show the analogy with a mathematician who appears in this novel. So in Japanese, so the title of the novel is Hakasen Aishita Sushiki, but so there are English translation version of this novel. So the title is The Housekeeper and the Professor. So in this novel, so a mathematician appears. And so due to the unfortunate accident, so this mathematician lost long-term memory. And so the mathematician only has 80 minutes memory. So over 80 minutes, so he forgot everything before that. So that is very similar to the modern AI because the modern maximum memory of the modern AI is about 200 kilo to 1 mega tokens. So this is correspond to the several hundreds 30 30,000 to the several hundreds lines of code. That is not small. That is big. But so that is not for enough for the long-term memory. And so within a session, so modern AI did auto compression. So that is a token limit by summarize all the things. And so that is useful, but still lossy. And so by repeating the auto compression many times, the ability of the AI becomes lower. And so in addition to that, so I should note that memory does not persist across a session. So if you close a session and restart a session, so AI forgot everything because AI has no long-term memories. So without external memories, so every conversation starts from zero. So that is a big limitation. And sorry, it's okay, no problem. Okay. And so in this novel, so a mathematician um, found a workaround for having the long-term memories. So as an external memory, so the mathematician uh, wrote a memo, and so mathematician pinned the memo to the chat like this. So for using AI, so we do similar things to have a long-term memory. So solution is very simple. So we use external memory, two-layer external memory. So in this, there are two kinds of memory. So the first kind is a very common and community convention. So the file name is typically cloud.m or agent.m. So in this file, so the basic rules and contract are written in this file. And so by using the AI, such as Claude, so by starting the session, so Claude automatically reads this Claude.md, and so they remember the rules and contract. And so they also remember what is project is, and so the convention in the project, and so they also remember the neighborhood rules. So sometimes so AI breaks the rules, but so basically AI follows these rules. So this is a first layer. And so second layer is my personal practice. And so I found this is very useful. So this act as a long-term memory. So the typical name of the file is log.md. So in this file, so I decoded the record of past event. And so in the AI session, so I've often asked AI, so please write these things, or please write this history in log.md. So log.md contains the session history or decision or hands-off contents. So by using this log.md, so AI can have long-term memory. So for example, so 1 week ago, so I asked the AI to implement this function. So that is recorded in this file. So I asked the AI, so please remember the function that is implemented in the last week. So AI see this log.md. So AI remembers the details of the implementation. So this file acts as an external memory. And so this is an example of the crow.md and log.md. So in preparing the slide for this seminar, so I first made the crow.md and log.md. So in the crow.md, so includes the purpose of this project. So this preparation directory for this seminar. And so I prepare the plan.md. So this contains basic plans for the talk. And so in crow.md, so there is a rule for writing log.md. So in log.md, so purpose should be written. And so unfinished tasks are split out into to.md or so. And so in log.md, so there is a record of preparing the slide. So about 1 week ago, I started to prepare the slides. And so what I did, what AI and I did written in this log.md. So this acts as a long-term memory for AI. Anyway, so let me move on to the second limitation. So this limitation is a very serious limitation. Namely, so AI is often lazy and wrong, as as this is very similar to human beings. And so I take one example from the Professor Liu's lecture slides on this computer hack. So in this slide, so I explain the typical laziness of AI. So this is a sample code for calculating the ground state energy of the Heisenberg chain. So this is the definition of the Heisenberg Hamiltonian. So E0 is the ground state energy. So this is a test for this code. The true ground state energy is minus 0.75. So the obtained energy is close to this energy. So that pass the test. But so for some reason, if the we think that if the test fails, so we get the 0.75. So that is a plus value instead of this minus value. And so in this situation, so if we ask AI to fix or fix a bug in this code, so what AI do? So in typical case, AI edit this value, namely the difference value in the original code. So they edit the minus 0.75 to the 0.75. And so, of course, bug still exists, but test passes. And of course, that's physics wrong. So this is a typical behavior of the AI. So for AI, so for the simplest and the shortest solution is to modify this value. Of course, it is nonsense, but AI often did this thing. And so, of course, to avoid this is a big problem, big issue for the development of the codings. And so this result indicated that review is harder than generation because so generating code is very fast. So AI generated a very long code, and so it is very difficult to review that long code for human beings. So if we should think other things. So because of this speed asymmetry is inherent in the AI coding. So to avoid this kind of things, so we should do other things. So there are no perfect solution to this, but so one typical and one effective solution is making and reviewing the plan or design before implementation. And so by writing the plan and design before implementation is very important point, important procedure. And so to write a plan and design, so it is useful to use the skills that is open in GitHub repositories. So one famous example is a superpowers. So that contains several skills. So that contains system engineer wisdom. And so I frequently use brainstorming skills. So this is skills for writing the plans. So based on the step-by-step questions. So if I want to implement some function in the code, so the first typical phrase is before implementing this function. So I ask AI, so let's do some brainstorming using the skill of the brainstorming in superpowers. So this is a typical phrase to ask AI. So for example, so by asking such as Claude, so Claude gave me a step-by-step question to define the details of the plan. And so then finally, so Claude write a plan.md or design.md. So based on this plan and design, so AI automatically implemented implementing the function, namely the AI automatically code. But my recommendation is before implementation, so it is better to have a review by other AI, such as Codex. So typical phrase for reviewing for AI is, please do a thorough check for any latent bugs or hidden defect. So by asking this, so another AI often find several serious bugs in plant.md. And so again, I ask Claude, then please check the result of the review. And so I do this cycle 2 or 3 times. And so after the 2 or 3 cycles, so there is no serious problem. After that, so I asked AI, please start to implement. So through this procedure, so I expected that so there are no trivial bugs or trivial defects in the implementation. So this indicated that so it is very dangerous to trust a single AI run. So instead of that, so by using a skill, so it is better to prepare the plan or design. So that is a document for implementation. And so reviewing that document is an essential part for effectively use AI coding. Anyway, so this is an example. So several weeks ago, so I was asked my colleague to modify the code for the quantum Monte Carlo method. So my colleague says so he want to modify this code to treat a different lattice structures. So based on that, based on his desire, so I asked Claude, so write a design by using the skills of the superpowers. So then I asked Codex for review the plans. And so there are 3 rounds of the review and checks. And so in this review process, so Codex found 25 serious bugs in the original plan. So here I show the 2 examples. So one example is trivial bugs. So Claude proposed that so the program program can have this argument L. So L specifies system size. But in the original code, so L is already defined. So there is a serious inconsistency. Because of this, so if we specify the L in this way, L is 8, but so the code silently runs for the calculation for L is 100. So from this review, so Codex find this bug. And so another bug is a typical case of a lazy. And so Claude proposed that there should be the text picture must have 6 distinct elements. But the actual text picture has only 4 elements. And so 2 are duplicated. So Claude violated the rule. Claude violated the rule. So although so Claude itself defines the rule. Anyway, so through these reviews, so AI can find serious bugs or serious defects in the plan. And so based on the this review, so we can improve the accuracy of the plan. And so based on that accurate plan, so the AI automatically implemented the code. Anyway, so let's move on to my experience of agentic AI coding. Anyway, so the main part of this is rewriting mVMC in Julia. So mVMC is a software for many variable variation Monte Carlo method. So this is a variational wave function method. So by using this method, so we can obtain the highly accurate ground state wave function for strongly correlated electron systems. But mVMC is I think, very useful software, but the source code itself is very complicated because mVMC is optimized for massively parallel computing. Because of that, source code structure is extremely complicated. And so in many cases, so we always suffered from the messy structures of mVMC. So because of that, so in the last year, I decided to rewrite mVMC in other language. So modern language Julia. So originally, so mVMC is written in C language. So the length is approximately 20, 2,500 lines. And I asked a freelance software engineer, so he is Terasaki-san. And so he said, so by using AI, so it is not difficult to rewrite mVMC in Julia. So I asked Terasaki-san, and so he succeeded in rewriting the mVMC in Julia within about 3 days. And he said, so without writing a single line of code manually, so he did that. But this is just a prototype. So to confirm the validity of the code, so it takes about 3 months. But so after 3 months, so Terasaki-san succeeded in developing the beta version of Julia MC. And so at that time, so Julia MVMC passed a simple test for the simple Heisenberg model. And so based on this beta version, so I started to confirm the validity of the Julia MC. And so I have confirmed that the Julia MC produces a result that is identical to original C MVMCs. And so finally, so I released a Julia MVMC in this May. And so it is available in this GitHub repository. So if you are interested in, please take a look at this repository. And so from now, I explain so how to confirm the validity of Julia MC by using AI coding. So in the beginning of the February, so I have a beta version of the Julia MVMC developed by Terasaki-san. And so for the real variables, so Julia MVMC works well. All the energy well matches the original C MVMC. But I have found that if we use a complex mode, name the complex variables, so Julia MVMC shows a significant discrepancy from the C MVMC. So the energy, real part of the energy, the discrepancy in the real part of the energy. So this discrepancy is small, but if the algorithm is faithfully implemented, that should be the same. So there is some bugs or some defect in the implementation. So to check that, so I asked the AI, so please compare the result of CMVMC and the Julia MVMC. So in that procedure, AI did much more things. First, so AI compares the random number sequence. And so AI also compares the electron configuration in the Monte Carlo samplings, and so matrix element and parameters and so on. Yes, this is a very tough task. So we should handle the two different source code, which is written in C and which is written in Julia. So for usual human, it is impossible, but AI can do it. And so within about 5 hours or so, so AI did this tough task, and so AI compares everything. And so AI confirms that the random number sequence or electron configuration or matrix element they match. The result of the Julia MVMC match with CMVMC. So this result indicated that there are some difference in the source code itself. And finally, so I found that there is one line difference between C-mVMC and Julia mVMC. So that is not a significant bug. So that is just the seed of the random number generations. No. That is just some uh, specifications as starting point. So that is not affects largely affect the result, but so this difference causes a small difference of the energy. So by collecting this discrepancy, so finally I have found that the Julia MVC reproduce result by the CMVMC. So this layer by layer debug is not waste of time. So this procedure validates the Julia MVMC faithfully implemented the function in CMVMC. Anyway, so after that, so I have confirmed that the Julia MVC reproduced a result for the several different models. And so I have added the unit test in Julia MVC in the middle of February. It takes about 2 weeks. But after that, so because I am lazy, so I do not release a Julia MC. But so in the beginning of May, so I decided to release Julia MVC, and so I started the procedures. So first, I prepared the design for the public release of Julia MVC by using superpowers. And so according to this plan, so by using AI, so and AI did many micro tasks for public release procedure, and finally 14th May, so I released version 0.1 of Julia MVMC. Anyway, so here I compare the speed of Julia MVC with the CMVMC. So surprisingly, so I have found that the speed of Julia MVMC is, Julia MVMC is faster than CMVMC. I will explain the details of that. And so I did a benchmark on Otaka. So that is a supercomputer in ISSP. And so I performed the calculation for the Heisenberg chain. So L is a system size. And so this is elapsed time for Julia MVMC and CMVMC. And so I use a pre-installed CMVMC in Otaka. And so Julia MVMC is always faster than the CMMC. And so that is much more faster for the large system size. So this is a very surprising result because the Julia MVMC faithfully implemented the function in CMVMC. So I expect that the elapsed time should be comparable to the CMVMC. So to identify the origin of this speed up of Julia MVMC, so I inserted the timer in Julia MVMC for each functions. And so I identify the difference comes from this function. So this is the update MO2. So this is a function for calculating the inverse matrix using the Sherman-Morrison type formula. So for CMVMC, it takes 70 seconds. For Julia MVMC, just 14 seconds. So there are 5 times the difference. So to identify this difference, I see the source code. So this is a source code for calculating the inverse matrix. So the left side is a implementation in C, and so right side is the implementation in Julia. And I have finally found there is a legacy optimization flag, named the pragma loop no areas. So this directive is originally introducing in the optimization on K compute. And so for Fujitsu compiler, no areas works, and so it is used to for the explicit shimmed vectorization for this loop. But for GCC and ICC does not understand this directly, and so they just ignore it. And so AI understands the meaning of this directive. And so Julia mVMC, so AI introduce this turbo directive. So this enables this turbo directive makes this loop in the shimmed vectorization. And so for decades, so I did not know the existence of this program. And so I did not know this program does not work. And so Julia mVMC clarifies the existence of the non-shimmed loops. And so that is a bottleneck, silent bottleneck in CMVMC. And so to solve this problem, so I inserted the directive instead of this to the conventional or standard program. And so by using this program, so we force this loop in the shimmed, we, we can do the shimmed vectorization for this loop. And so we also found that the ICC does not fully optimize the shimmed directive for non-Intel CPU, such as AMD used in Otaka. So this result shows that the ICC is not a good compiler for Otaka. So by using GCC, so we can accelerate this calculation. So to perform the calculation of mVMC in Otaka, so GCC is a best option. This comparison indicated that. Anyway, finally, so CMVMC catches Julia mVMC. So this is a bottleneck functions. So for the pre-installed version and ICC, that is very slow. And so by changing the compiler, we can speed up, but that is not a vectorized. And so by using this directive, the the time of the CMVMC becomes comparable with the Julia version. So, of course, so Julia wasn't intelligible first. So the main origin of the slow of the CMVMC is a non-effective directive. So this result indicated a very unexpected result. So unexpectedly, the implementation in different language act as a profiler for detecting the bottleneck in CMVMC. So, but I want to note that so Julia is not always faster. So for several different functions, so such as this function, so Julia mVMC is slower than CMVC. So this result shows that by comparing the result or speed for different implementations, so we can easily identify the bottleneck in each language. So we can do the cross-language optimization in this area. So I have never imagined this would come true because, of course, the multi-language implementation, cost of the multi-language implementation is very huge without AI. But by using AI, so it is not so difficult. It is easy to implement this once scientific code in different language. And so by comparing the results, so we can identify the bottleneck or we can optimize um, source code for, for each language. So this cross-language optimization is a main advantage. I think the unexpected but a big advantage of multi-language implementation. Yeah, so in addition to the scientific code, so I enjoy the AI coding for making supporting tools. So one is a HPC flow. So this is a natural language interface to use HPC supercomputers. So this is a combination of the SSH and rsync. So by using this HPC flow, so I can submit a job to supercomputer by using the natural language. So this is a typical workflow. So I asked AI to please submit test job to Otaka using HPC flow. So Claude understands that, and so by using the HPC flow, so Claude automatically submit the job. And so then I ask, so what is the status of the job? So by using HPC flow, so Claude check the status of jobs. If the job is finished, so I asked AI, so please sync result, and so only important files. So from this instruction, so Claude use HPC flow and sync the result. And sometimes so Claude automatically plot the result. And so by seeing that plot, so I I interpreted the result. And so I asked the AI to check to do next check. So please submit as another job. So this makes me my research very easy. So because the job submission is a very time-consuming part of my research, but so by just asking AI, so AI automatically submitting jobs and sync the result. So that is very convenient. And so another example is archive shared. So this is apps for sharing archive papers. So that is so these apps get a list of the archive new papers. And so based on that list, so we can see the title and abstract of the archive papers. And so if we are interested in, so we can push this like button. And so there is a ranking based on this number of the likes. So because of that, so we can see which paper attracts much attention in today's archive. So that is written in the JavaScript. So I have never write a code in JavaScript, but for using the AI coding, so I can build these apps within just 3 days, and so I can enjoy the archive paper sharing. Anyway, so I explained the three examples, and so without AI, so I could not have achieved any of this. So from scientific code to the supporting tools or sharing tools, it is very easy to make this kind of the tools by using the AI coding. Anyway, so this is a summary of my talk. So AI coding is very powerful, and AI coding is very fast. So typically 100 times faster than the human coding. So by using that AI, so we can now do things that are previously impossible. So I recommended you to use AI and enjoy the things that were previously impossible. And so I think today is a very exciting time for people like me. So who don't have particularly strong coding or mathematical abilities. So I'm not so strong, but so AI augment my own capability of coding or mathematics. But there is a problem. So in the long term, so it is expected that the cost of AI usage will be increasing. Um, and so many people use AI. I expect that the competition becomes severe and severe because so we can easily obtain the result by using AI. So that is a problem. And so another problem is knowledge is still needed. So if we have deeper knowledge, so if we have deeper knowledge, so we can use AI effectively. In other words, so to use AI effectively, so we should have a deeper knowledge on the topics. So knowledge input or studying will always be necessary. And so in the last part, so there is also problem with the educations. So using AI effectively requires knowledge and experience. So without experience, it is very difficult. I think it is very difficult to do software development. But in this AI era, so using AI is is common. So in that situation, so the young student lose a chance to chance to have experience on handwriting code or learning the structure of the code. So when and where will students gain the experience on coding itself is I think so that is, I don't have any good idea, but is a serious problem we should consider. Anyway, so that is all. So thank you for listening.